Hello,
And welcome.
my name is Ryan Harris.
And I'm Grant Gillespie.
Have you ever been to a hospital and wondered what occurs when blood types are mixed together?
That truly is a scary thought. Hospitals are supposed to be safe, right? What
Right.
could possibly go wrong?
Today we will investigate what occurs when people combine unlike blood types. It's important to note that a person's blood type comes from differences in specific antibodies, which influence whether a person has A, B, AB, or O blood types. There are also antigens that make the blood either negative or positive.
Antibodies are incredibly important because when talking about blood transfusions, since a mistake could easily cause someone to experience traumatic pain and or irreversible side effects.
Grant, could you please elaborate on what antibodies do in our bodies?
An antibody is a Y-shaped protein that is produced by plasma cells and is used in our immune system to identify and destroy pathogens.
In the event of a mistaken blood transfusion, the antibodies of the host cell or body attack the foreign cells. Much like a small battle, the antibodies attempt to remove the cell and therefore cause pain to the person who's receiving the blood. To illustrate this, me and Grant will place like blood substances or synthetic blood together in an attempt to show how the blood adjusts and coagulates to the different blood types.
In our investigation, we will walk you through an experiment wherein we compare and contrast what occurs when the blood types A, B, AB, and O are combined. These are the materials needed in the experiment: synthetic blood, trays, antibody agents, and toothpicks.
Step 1. Find your synthetic blood and place it in your petri dish. Then select your antigen, variable A or B. In this case, B is being put in the petri dish. Following that, put in the other antigen, in this case A. Once this event has been done, grab your toothpick and slowly or vigorously begin to mix it. Flip over the toothpick and then use the other side to do the same to the other sample.
Repeat this process for the next 3 petri dishes. If the blood is A-type blood, then it will react to a B-type antibody. If it is O-type, it will react to both A and the B antibody. If it is AB, then it will react to neither A or B. And if it is a B-type blood, then it will react to the A-type antibody. In this tray, the blood has reacted to a B-type antibody, making this blood A-type.
In this example, the blood reacted with both antibodies, A and B. Thus, we can conclude that the blood type is found to be O. This is shown by its coagulation. In this example, the blood reacted with neither, meaning it did not react with antibody A or antibody B. Thus, we can conclude that it is AB blood. As stated before, each blood type is based off their antibody. If a blood cell has an A antibody, it is deemed A blood. For B, it has a B antibody. For AB, it has both A and B antibodies. And for O, it has neither of those antibodies. In this experiment, by introducing B antibodies to A blood type, we are simulating how the antibodies in A blood will react to the antibodies in B blood. By demonstrating the effects of mixing antibodies with synthetic bloods, our understanding of what occurs when blood transfusions mess up or have a mistake is heightened. The body's way of slowing or stopping foreign blood that it deems to be bad for itself is a process called clotting. This means that the blood actively tries or attempts to destroy the foreign blood cells. In doing so, it clots up the blood vessel and slows down the movement of the foreign blood into the cardiovascular system. In conclusion, when two blood types are mixed, the result is quite catastrophic for the individual.